In this video, we have to solve now chapter 4, exercise 4.1. Exercise 4.1 is related to the integrals. We have to solve or we have to integrate some functions. Write down the indefinite integral of each of the following. We have to integrate all these functions from question number 1 till question number 12. For that purpose, in page number 131 of your SM Yusuf book, we have a table of integrals. These formulas are used in this whole chapter to solve or to integrate the functions that are starting from formula 1 to formula 35. These formulas are given here. These formulas will be needed to solve this chapter 4 that is related to the integration. The last three formulas 33, 34 and 35, these three formulas are used in exercise 4.1, these three questions 10, 11 and 12. Now starting from question number 1 of 4.1, we have to integrate some functions. The first function that is given is 0. We have to integrate this 0. When we will integrate some 0 function, we always get a constant, because we know very well integration and derivation are opposite to each other. So whenever we take a derivative of some constant function, we always get 0 in answer. And if we integrate 0, we will get back this constant. So the integration of 0 is always constant. Integration of square root x. Just open this square root as in power form. In the table of integration, there's given some rule that integration of x raised to power n dx is always equals to power plus 1 divided by that power plus 1 plus this constant. So here the power is 1 by 2. So we'll integrate it like power plus 1 divided by that whole power. 1 by 2 plus 1 will be 3 by 2 and divided by 3 by 2. That 3 by 2, when we'll move it up, it will be reciprocal. So 2 by 3, x raised to power 3 by 2 plus c is the answer of question number 2. Question number 3 says we have to integrate 1 plus x over x. Now we have only one function in a denominator. We can separately divide it with 1 and x 1 by 1. So it will be 1 over x plus x over x. But remember this thing, that if we have x over x plus 1, we cannot divide it like x over x plus x over 1. This is wrong. Because in the denominator we have adding this x with 1. We cannot separate it. But if we have one function in denominator, we can separate it like this. Just divide it with 1 and also with x separately. So 1 over x and x over x, we will get 1. Just split this integration to 1 over x and then to 1. Always this is given in the table of integrals as well, that 1 over x, integration of 1 over x is always ln x. And integration of 1 is always x, and the constant of integration is written in every answer. Question number 4. X square minus 1 over x square plus 1. Now you see this is an improper fraction. Improper fraction means the power of the numerator is equals to power of the denominator. This is an improper fraction. Like if we have 4 over 2 written, this is also an improper fraction because it is not in the simplified form. It can be divided like this. But if we have 3 over 7, this is a proper fraction. If we have the same number in equal form, this is also an improper fraction. So again we have here improper fraction because both the function highest power is same. So we can make it proper fraction by dividing. But also there is another method. If you don't know how to divide two functions, then we can follow another method. That is, we will make this denominator in the numerator. How we are going to make it? We need x square plus 1. Here we have x square plus 1. I will make this x square plus 1 in the numerator. And how I am going to make it? Just add plus 1 If you are adding plus 1 here, then also you have to subtract. So I have added and subtracted 1 here, so that I can make the same thing, x square plus 1, x square plus 1 here. Now this x square plus 1 will be taken aside, and this minus 1 and this minus 1 will be solved, and it will be minus 2. Now I can separate these two things. Just divide x square plus 1 this function and x square plus 1 with this one. So we will get x square plus 1 over x square plus 1 minus 2 over x square plus 1. This whole will be cancelled and we'll get 1 minus 2 over x square plus 1. Now we can easily split the integral. Integral will go to 1 and also to this function. So integral 1 dx minus 2, this is a constant, we can take it outside, 1 over x square plus 1 dx. The integration of 1 is x, and we know very well the integration of 1 over x square plus 1 is always tan inverse of x. This is a direct formula you have to use through your table. And you have to memorize the table for your exams as well. Question number 5. Tangent square of x has no direct integration, so we have to simplify it towards the secant square of x, because the secant square of x has integral formula, but tangent square of x has no integration formula. We know very well that 1 plus tangent square of x is equals to secant square of x. So tangent square of x can be written as secant square of x minus 1. So replace tangent square of x with secant square of x minus 1 and separate this integration. This is a direct formula that is given in your table. The secant square of x integration will be tangent x. 1 has integration x, and apply the constant of integration plus c. Question number 6 now. Cot square of x. Again, cot square of x has no direct formula for the integration. So same, we will just split it in using some identity. We know that 1 plus cot square of x is equals to cosecant square of x. So cot square of x will be equals to cosecant square of x minus 1. So replace it with this formula, separate the integration, and cosecant square of x has the direct formula of integration minus cot of x, and 1 has integration x, and then apply the constant of integration here. Now question number 7 says we have to find out the integration of cos square of x. Again, cos square of x and sin square of x has no direct integration formula. So always keep it in your mind, whether we are doing the integration by parts or whether we are doing the simple integration. Whenever we have cos square of x or sin square of x in our integral, always use this formula. Because normally cos square of x and sin square of x also come in integration by parts as well. So we will just replace cos square of x with this formula. Just memorize this formula, that this is equals to 1 plus cos 2x divided by 2. And the sin square of x is always equals to 1 minus cos 2x over 2. Both the formulas are same, but with the opposite sign. Now we can split it. We can write it like 1 by 2 plus cos 2x by 2 and just separate the integration. This 1 by 2 is constant. This will be treated outside. This 1 by 2 is also constant. Treat it outside. This integration will be equals to x and cos 2x. The integration of cos ax dx is always equals to sin ax over a. This a will come here. So cos 2x will be sin 2x divided by 2. Just simplify that, we will get this answer. Now comes sin square of x, question number 8. The same thing happened in this question number 8, but with this minus sign. I hope you understand it now, that what you are going to do when you will get cos square of x and sin square of x in your integration. Question number 9. Integration of square root 1 minus cos x. Now we have to break this square root. The method for breaking the square root is, this x can be written as 2 into x by 2, because 2 into x by 2 can get back to x. So just replace it. We can use now the identity here. We know very well that cos 2 theta is equals to cos square of theta minus sine square of theta. So just replace it with cos square x by 2 because the angle here is x by 2 minus sine square of x by 2. Open this bracket and apply this minus sign inside. We'll get this equation. Now simply this 1 minus cos square of x by 2. This will be replaced with sine square of x by 2 because we know that sine square theta plus cos square theta is always equals to 1. So 1 minus cos square theta will be sine square of theta. Theta here is x by 2. Sine square of x by 2 plus sine square x by 2 is 2 sine square x by 2. This can be separated. Split the square root. We'll get square root 2 sine x by 2. Take this constant outside. Now we can integrate sine x by 2. This sine x by 2 will be integrated as minus cos x by 2 and the derivative of this part is 1 by 2. So we'll get minus 2 under root 2 cos x by 2 plus c. Now question number 10. Question number 10 says you have to integrate square root 4 minus x square. I told you earlier for question number 10, 11 and 12, we have to use the ending formulas of that table. This is of the same format. I have write down this formula already. 4 minus x square. It can be written as a square minus x square. So we can use this formula. So just write it in square formula. This is a now. So a here is 2. Replace a in this formula with 2 and we will get the same answer by using this direct formula. This formula is difficult one, but you have to memorize it for solving these kind of questions. Just find out this a and replace this a in this formula. Now question number 11, 4 plus x square. It is of the same format as a square plus x square square root, like this formula. This is plus sign, so we can also write it like x square plus a square. There will be no change if we just exchange it because we are having plus sign here. So just use this formula, x into x square plus a square square root divided by 2 plus a square over 2 ln x plus square root x square plus a square divided by a. Just find the a here. A square is 2 square, so a is 2. So just replace in place of a here in this formula with 2 and we will get this answer. Same in question number 12. It is of the format x square minus a square. So use that formula and replace a with 2 here because the a here is 2. Replace a in the whole formula with 2 and we will get the answer. This exercise was the easy one as compared to the remaining coming exercise 4.2, 4.3 and 4.4. After this exercise, we will do soon the exercise 4.2, 4.3 and 4.4.